Hello 108 students, Mr. McHugh back here with you on page 2 of, whoops, guess what? Got to turn on my pen here. Sorry about that. Page 2 of section 7.4. That's a little better. And we now are going to take these from the last class notes in the last video. Going to take the two examples where we determined the restrictions, and now we are going to find the solutions for x. What value of x will make these equations true? Now, so I've got my steps number here, 1/2, 1, 2, 3, and 4. Step 1/2 says always check for restrictions, which we did from the last class notes and video, and x cannot equal 0 here, and that's because you set 2x not equal to 0, x does not equal 0, and right here also is a dead giveaway. Okay, now here's the big step. You want to train yourself. You look at these problems, and the first thing that catches your eyes is, oh my word, I have got rational expressions all over the place, or aka I've got fractions. The best way to get rid of fractions, to deal with them, is to remember the phrase, determine the LCD and multiply that across the equation, across the board, and clear the fractions, aka REs. Okay, so take your time. What would the LCD be? Look at each denominator. X has got to be part of it, 2 has got to be a factor, and 2x. Okay, so x times 2 is 2x, and that would be your LCD. Okay, now that's the most important decision here, and you got to get the correct LCD, or the rest of your work will not pan out correctly. How does this concept of clearing out the fractions work? Take every term, or RE, of the equation, or multiply across the equation or across the board, I say. So the LCD is 2x. You multiply that by every term. Now I rewrote it so you can see the 2x clearly written, multiplied against every term. Now you've maintained balance on the equation because you took every term and you multiplied it by the same amount, aka 2x. Now look what happens. 2x divided by x, class, the x's cancel out and you're left with 2 times 2, and that drops your 4. Now aka the fraction's been cleared. Okay, the reason the fraction's been cleared is because when you determine the correct LCD, every denominator is a factor in the LCD, and it's going to cancel out. Okay, let's see if this is true. 2x divided by 2, the 2's cancel out, and you're left with -3 times x, producing -3x. Here's your equal sign. Now you've got 2x in the numerator, 2x in the denominator. They cancel out, and you're left with 7. Okay, what I love about this process is these problems look nasty to begin with. All you got to do is figure out the LCD, multiply it across the board, and clear out the rational expressions or fractions, and boom, you're left with problems that are fairly easy to manage as far as algebra goes. Okay, now from here you're in what I call mop-up operation here. Got to isolate -3x, so what? -4, I didn't show the work here. 7 minus 4 is 3. Divide by -3, and boom, x equals -1. Now, before you go putting this into Math Lab, what was the restrictions? X cannot equal 0, so therefore you are okay with that answer. There's the final solution. Okay, remember, you got to do that check full. You got to check the restrictions. If you don't, you're going to get burned. So let's just remember that. Okay, now let's go down right here. Let's go to example 3. We did this problem on the last page, like I mentioned before. We've already determined the restrictions. We took each of these factors, x minus 3, and determined what x cannot equal. Bottom line, x cannot equal a positive or -3. You got to remember that, positive or -3. Now look, here's the deal. You cannot find any shortcuts here. You got to go through here. It's nice to know what the restrictions, what x cannot be equal to, but you've got to figure out what you find for solutions for x, and then you've got to make the comparison. Okay, so what's the LCD? Let's go to step 1. Each denominator must be a factor. So x minus 3, x plus 3 have got to be factors, and x squared minus 9 is the difference of squares, and these are the two factors, so this is the LCD. Okay, take the LCD and multiply it by every term. So I'm multiplying it here, here, these are little arrows, and here. And that's what I'm trying to show. LCD, LCD, LCD. Okay, now look how I put it as x squared minus 4. That's okay, because they're equivalent. Okay. Now what's the beauty? You should clear out the fractions. X minus 3 in the denominator cancels out with x minus 3 in the numerator. Don't forget, you've got multiplication going on here. So what's left? 2 times the quantity x plus 3. Now I would just clear out the fractions or write what's left standing, then deal with simplifying. Over here, x plus 3 cancel out. You've got negative 3 times the quantity x minus 3 equals what? X squared minus 9 divided by x squared minus 9. They cancel out, and you're left with 12. Okay, so here we go. There's that magic. Multiplied by the LCD, what looked like a nasty problem turns out to be fairly manageable now. And we could go back here and do some basic algebra simplifications. I see parentheses, so the distributive property would be my next step here. I got 2x plus 6. Now watch this. You got minus 3 times x. That's fine. Minus 3 times a minus 3 is a positive 9. Watch the signs. And so now you've got that. So this line right here. Can I combine like terms? 2x minus 3x is a negative x. 6 plus 9 is 15 equals 12. Take your time, one step at a time. Each time you do a step, a process, the problem gets easier and easier. You're working down the funnel, just like we did back at the beginning of the semester. Solve for isolate negative x, minus 15 on both sides. I got negative x equals negative 3. And finally, multiply or divide by negative 1 on both sides. Negative times a negative produces a positive x. Negative times a negative is a positive 3. Now you do all that work. Okay, and you go back to step number 4. You're ready to put x equals 3 into the solution. You worked hard to get it. But what's the restrictions? X cannot equal what? Plus or minus negative 3. Therefore, x cannot equal 3. Is not a solution, so therefore you have to put the null set as your answer, null. Remember, you've got the either you put the symbol there, or you make sure you put the or you put the empty brackets. Okay, there you go. We've done basically a couple good problems here with rational expressions in there, and you just got to remember to check the restrictions. Determine the restrictions and check them at the end. Okay, Mr. McHugh, I'm going to check off here on page 2. We're doing pretty good here. When I see you back in the next video on page 3, we're going to try some more problems with the same idea of determining the LCD and multiplying it. Okay, I'll see you then. Bye.